Good morning, good afternoon, good evening. Welcome back to Chapter 36, Population Ecology. We're talking about the two different methods of growth, two different curves that we see of growth. And that the first one was logistical growth, and that's where once a population reaches close to that carrying capacity, the growth slows. The other growth curve is exponential growth. Exponential growth is where the population increases slowly at the beginning and then increases very rapidly. Our population of hamsters was an example of exponential growth, doubling each time. Bacteria do this. Bacteria grow. They double each time they reproduce. Here we see a growth curve for a population of rabbits. Time in months. Grows very slowly in the beginning, 150 individuals, and then once we get, again, as time goes on, it doubles. There's a reason why we say breed like rabbits, because they reproduce very quick. We'll talk more about the reproduction of rabbits in just a little while. But this is referred to as a J-shaped curve. The J-shaped curve is exponential growth, growing very little in the beginning, and then growing really fast towards the end. Exponential versus logistical growth. They seem to be very similar in the beginning, but once we hit the about halfway through, we can see there's quite a bit of a difference. K refers to that carrying capacity. What has happened to the rabbits? They have shot past that carrying capacity. What's going to happen to the rabbits? They're going to die because they have gone beyond, they've gone past what their environment can support. Some populations will have zero growth. Zero growth will be no net increase in individuals. Births equals deaths, and immigrants equals emigrants. The U.S. is approaching zero growth. We had been approaching zero growth, but then we had quite a bit of immigration from Central and South America. Europe has had zero growth. Many countries in Europe have had zero growth for a long time. The number of births and deaths are the same. Number of immigrants and emigrants are the same. Population, human population. This is a little bit old. We're now up to 7.6 billion humans. It grew rapidly in the 20th century. Now in 2020, the human population is roughly about 7.6 billion. I was born in 1972. In 1972, there were about 4 billion people. What has happened? I think it's actually 3.8. What has happened to the population of the planet just in my lifetime? It's doubled. What kind of growth is that? Is that logistical growth, or is that exponential growth? It's exponential growth. I believe the population of the world around the turn of the century, around 1900, I think it was like 1.2 billion people. So in 120 years, the population of the world has increased by like 6 times. That's a little scary. It is frightening, but there is some good news, and the good news is that the growth rate of the human population is slowing. We are starting to hit that logistical phase where our population increase is about to level off, it seems. When we talk about this, we imagine, our hamster situation. If it's humans and the Earth is our cage, we don't know at the moment how much, what is the carrying capacity for humans are on the planet. We have some guesses. Some people think the guess is about 10 billion, excuse me. The guess is about 10 billion people. Some people think it's closer to 20 billion people. we're not exactly sure what the carrying capacity of the Earth is for humans. It's probably closer to the 10 to 15 than it is the 20. And the numbers are suggesting that we're leveling off because we're approaching that carrying capacity. And we'll talk more about that in just a little bit. The population of humans is projected to increase at least through 2050 until we finally hit something close to the carrying capacity. And the thought of humans actually hitting the carrying capacity of the Earth is actually kind of scary, because what happened to the hamsters? They shot past the carrying capacity because they had plenty. Everyone had plenty. And because everyone had plenty, they kept having lots of babies. It's frightening that there could maybe be a crash. We'll talk a little bit about population density again later on, but when you have a very dense population, what happens is there's resource scarcity, which means not enough food, not enough water, not enough shelter, or any one or all of those. It also means that disease spreads a lot easier when you have a very dense population. Any of this sound familiar? Dense population like China. China has a population of 1.3 billion people. Remember, what does the 0.3 mean? The 0.3 means 300 million. What's the population of the U.S.? U.S. population is about 330 million. So that means that the 0.3 in China's 1.3 billion is about the same as the population of the U.S. in about the same territory, the same size, the same landmass. This is why diseases spread so quickly and so easily over there. The reason why they spread quickly and easily over here is another reason. This is a graph of the population of humans over the course of history. We start way back here, 8,000 BC, very, very, very long time ago. This is in billions, so this line right here is a billion, and notice how there was not anywhere close to a billion people, 10,000 years ago. Population starts to increase very slowly, very slowly. Does this look like that logistical growth, or does this look like a J-shaped curve? This looks like a J-shaped curve. We start to increase quite a lot around here once we figured out how to grow crops. Once we figured out how to, here is the Industrial Revolution. This is when we figured out how to use coal and other things to be able to power the industrial machine. Once we did that, we were able to make lots of food. Once everybody had as much as they wanted, what happened? It starts to increase. Very interesting to note, bam, that major decrease is the Black Plague. We didn't cross 1 billion people until about 1900. And this stops 20 years ago in 2000. It stops at 6 billion people, and we've got another 1.5 billion after that. Excuse me. So here we see population growth of, where is this? So this is a growing population. We have lots of young, very little old people, and these bars keep moving up. This is when they were born. But notice that after this growth phase, now we're seeing a zero growth phase. And this is an estimated population of each, what we call cohort. A cohort is a group of an age group. And in this cohort, we can see that now we've got zero growth. That the births equals deaths. And we're not putting on lots and lots of babies. Very interesting to note, though, is this is males on that side and females on this side. What happens as we reach these elderly years? There's more women than there are men. Women outlive men. This is a great graphic. I really like this one a lot. So this shows fertility rates by country. Again, if you can't see this very well on the screen, I strongly encourage you to bring this up on the PowerPoint of your own so that you can look at this closely. So this is fertility rates in 1970, about the time I was born. If it's blue, that means that each woman is having, if it's light blue, they're having 2 to 3 kids. If it's dark blue, each woman is having 1 to 2 children. And at this point, we can only see dark blue here around Scandinavia. Light blue is a lot of other Western countries like Australia, almost all of Europe, Russia, US, and Canada. We'll skip on to orange and to pink. If it's orange, that means that each woman is having 5 to 6 children. You see these big areas of orange, India, China, parts of South America. Pink is each woman is having 6 to 7. Purple, each woman, the average woman is having more than 8 children. And we have a couple countries here in Central Africa that have their fertility rate is 8 kids per woman. This means tons of growth. If each woman is having 4 times replacement value is 2 kids. Mom and dad have 2 kids that are replacing themselves. That's 0 growth. If you have 3 kids, that is slow growth. If you got 5 or 6 kids, that's triple replacement value. That's a lot of growth. We move on from 1970 to 2014, about 5 or 6 years ago. We move on 40 plus years, and this is the same color scheme. Now look what has happened. Dark blue still means 1 to 2 kids, and now most areas that were light blue are now dark blue. Light blue is 2 to 3 kids. The US is about the same, though we did go from, I think, 2.5 kids down to like 2.1. We still have roughly the similar growth. But look at South America, huge change. 5 to 6 kids in Brazil and Northern South America. Now Brazil has gone to 1 to 2. Northern South America is 2 to 3. Again, look at Africa. Oh, look at China. China went from 6 to 7 kids per woman down to 1 to 2. And actually, the China in the 80s implemented what was called the one-child policy. Families could only have 1 child at a time. So that's how they went from 6 to 7 kids to 1. And look at Africa. We don't have any purple left anymore. We don't even have any red left anymore. We do have a couple countries that are still pink. But most countries have moved down quite a lot. One thing, very interesting thing to note, the reason why, or the way in which, one of the reasons why this change has happened in this 40 years is almost exclusively due to education. And specifically, it is due to female education. It is not that they're being taught birth control. It's not that they're being taught to have less kids or whatever. It simply means they're being taught. The more educated a population becomes, the more the birth rate slows down. Specifically, the more education a woman has, the older she is when she has her first child. And if a woman's childbearing years is roughly about 30 years, say from age 15 to 45, if we push that first kid from 15 to 25, we have reduced by half, or about 2/3, the number of kids she could have. And most women's childbearing years are between 20 and 40. So we're reducing 10 years. If you go from 20 to 25, or 25 to 30, now you're greatly reducing the number of childbearing years she has, and that therefore greatly reduces the number of children she will have. What changes, what has made the difference in the birth rate in the world? And that is education. The more educated your population is, the slower the growth rate will be.